Hi, this is Ahmed. In this video, we will talk about the correlation, covariance, and collinearity. We will also look at how these techniques are related with each other. First, let us understand what is covariance and how it is helpful to us in our day-to-day analytical projects. So, the covariance of two variables x and y in a data sample measures how the two variables are linearly related. So in a very simple terms, we use covariance to know the dependency between these two variables, to understand how these two variables are varying with each other. So it is a measure of how much the two random variables vary together. So it is very similar with variance, but in case of variance, we use a single variable to know the variability in a data point. But in case of covariance, we consider the two independent variables to understand the variability between two independent variables. So we generally calculate the covariance for numeric variables. So let us take an example to understand better the concept of covariance. Suppose example, I have two variables, height and distance. Height measures in feet and distance measures in kilometer. And as the height increases, distance is also increasing. It means that these two variables are highly correlated with each other. It means that these two variables have high dependency between each other. And in another case, if the height is increasing but the distance is decreasing, it means that these two variables are negatively correlated with each other. Even though in this case, in the second case, the two variables have dependency but in negative manner. So here's the formula to calculate the covariance between two variables, and the denominator represents n minus 1. The same rule applies here as well. If the data is sample, then the denominator is n minus 1. If the data you are considering is the whole population, then the denominator will be n. So a positive covariance would indicate the positive linear relationship between the variables, and the negative covariance would indicate the positive. Okay, let us look at the visualization, then it will help us to understand better the concept of variance. So guys, look at this. The x-axis is my time and y-axis is my returns. So in this visualization, as the return is increasing, the time is decreasing. It means that these two variables are negatively correlated with each other. But the problem with covariance is the scale which we are going to use. The scale, I mean to say the units. Like example, in our previous example, the height and the distance. Height we measure in feet and the distance is in kilometer. So when we calculate the covariance between these two variables, the number that represents the covariance depend on the units of the data. So it is very difficult to compare the covariance among the data set that have a different scales, because the height is in feet and the distance in kilometer. So it is very difficult to measure because the feet can vary. The height can vary from 1 feet to close to 10, 15, 10, 20 or max to max 100 or 200. But if you look at the distance, it could vary from thousands and lakhs as well. So the difference in the scale will vary, and that's a problem with covariance. Because if I say that the covariance value is 3000 and the 4000, so we may not able to track whether it is a highly correlated or medium correlated, because there should be some range depend on which we can decide whether it is a highly positively correlated or it is a medium correlated. Because suppose example, I have calculated a covariance and it got a covariance of 3000. So for this particular data set, the 3000 may be a highly positively correlated, but for another data set, this 3000 may be the medium correlated value. So this problem we are avoiding using the correlation parameter. So let us understand what is correlation, which is very similar with the covariance. Correlation. So basically correlation is a scaled version of covariance. Correlation tells us the same. It tells us the dependency between two independent variables. It tells you how strongly pairs of variables are related, how strongly two independent variables are related with each other. But the only difference between covariance and the correlation is the covariance have the no range. The value of the covariance will vary from 0 to infinity. But in case of correlation, the value ranges from -1 to +1. If the correlation value is -1, then we can say that this is highly negatively correlated with each other. If the correlation between two independent variables is 0, it means that there is no correlation between these two variables. And if the value of correlation between two independent variables is 1, then we can say that these two variables are highly correlated with each other. So now let us see how do we calculate the correlation. So the correlation is nothing but the ratio of covariance and the standard deviation. So when you divide the covariance with the standard deviation, will give you the correlation, which is in the range of -1 to +1. Now let us understand why do we need to go for correlation. So we go for correlation to avoid the redundant information in the model. So let us understand the importance of correlation with the model perspective. Suppose example, I have a 10 independent variables and now I want to build a model on the top of it. So I will consider the variables which are very important to develop my model. So if the two variables are carrying the same information, which means that if suppose example, if two variables are highly dependent on each other, it means that these two variables are carrying the same information, then we will consider only a one variable. So to evaluate the metric, to evaluate the level of dependency between two independent variables, we go for correlation. So correlation, covariance and the correlation is a very important parameter or metric in case of transactional data. Transactional data, I mean to say the financial data. So generally the correlation and covariance used in banking, finance and insurance companies. So now let us look at the visualization to understand the correlation better. So guys, look at this. Here the x-axis is height and the y-axis is in distance. So if you look at these two values, and the red and the yellow blue dot indicates the data point which are falling on the space. So as the height increases, the distance also increases. It means that so this is the positively correlated data. So as I told you, the correlation value ranges from -1 to 1. The correlation of this visualization could be 0.7, because if it is a highly correlated, I mean to say the correlation value is 1, then these values could be very close to each other. Even though it will be linearly proceeding, but these values could be very close to each other. It means that the variance between these data points will be very less. So when you calculate the correlation between two independent variables, the value which we get out of the correlation test will shows how good the correlation is, not how steep the line is. So when we get a raw data from a client and when we proceed further to develop a solution on the top of it, so as a part of data cleaning and data pre-processing and data transformations, so we apply the correlation analysis on the top of it to understand the data better, to understand the dependency between two independent variables, and to know whether the two variables are highly correlated or not. Okay, so that is called the correlation analysis, which we apply on all the data set. Now let us understand what is multicollinearity. So guys, as I told you that uh, to develop any model, so we need to consider a very important variables. Suppose example, I have a 10 independent variables. Out of these 10 independent variables, two variables are highly correlated with each other. So if we, without deleting a single observation, without deleting, and if we consider the independent variables which are highly correlated with each other, that will have a negative impact on our model. So let's take an example and understand why do we need to remove the highly correlated variables. Suppose example, if 10 people are going on a mission, and out of these 10 people, if two people are carrying same information, then we don't need to send the two people here. We can drop one people from the whole 10 people bunch, because that will in turn impact on your time, infrastructure, and the cost which you are going to incur on the sending the 10 people. So it's that same rule apply here. So when both the variable are carrying same information, then why do we need to send both the variable to develop a model? Because in turn it will increase the complexity of the model. It will have an impact on your regression coefficient. I mean to say the output of a model. So when you send all the independent variable without checking the correlation between all the independent variables, that will lead to a problem of multicollinearity. So multicollinearity is the occurrence of several independent variables in a regression model which are very closely related to each other. So there are multiple problems occur when you face the multicollinearity problem in the model. The first problem is collinearity tends to inflate the variance of at least one estimated regression coefficient. So guys, as of now, just understand that it will reduce the variance of independent variable which try to explain your target variable. So this sentence you may not understand now, but when we proceed further, when we understand the linear regression model, then you can able to relate this sentence with our regression model output. Okay, so guys, when you develop a regression model, so you will get some coefficients. So when you suppose if you have a multicollinearity problem in your model, so that will have a negative impact on your model output. So what it will do, it will change the sign of a regression coefficients. Suppose if the regression coefficient should be 0.25, then because of multicollinearity, it will change the sign of the regression coefficient. It could be minus 0.25. Okay, so there are multiple ways to deal with the multicollinearity. So first thing is to check, to apply the correlation analysis and reduce the redundant variables for developing a model. The second way to improve is even though if the model contains the multicollinearity, we need to ignore it, but in case of the collinearity exists in the dependent variable, it means that if the prediction of y values is the object of your study, then collinearity is not a problem. So what does it mean? It means that uh, if the dependent variable and the target variable is highly correlated, then we need to consider all both the variables. Then if you are facing a multicollinearity between the target variable and the independent variable, then we don't need to remove any variable. So that multicollinearity could be accepted, but there should not be a multicollinear effect between the independent variable. So guys, that's all for today. I look forward to see you next time when we will be looking at the different statistical tests like ANOVA, hypothesis testing, and chi-square test. So till then, happy learning.